When we consider your decision of how much to work, we would usually just model the trade-off you face between leisuring and consuming. When we consider your decision of how much to save or to borrow, we would usually just model the intertemporal budget constraint between consumption now and consumption in the future. Of course, when you think about how much to work now, you might be thinking not only about how much you want to consume now, but also how much you want to consume later, perhaps in retirement or perhaps next summer. Your intertemporal savings decision may therefore be wrapped up with the decision of how much to work versus how much to consume now. There may therefore be circumstances where we want to model not just the intertemporal decision by itself, but also the consumption-leisure decision together with the intertemporal decision. We'll give an example of how a budget constraint might arise in that case here. We'll think about the case of you deciding how much to work this summer in order to finance both your consumption this summer and next summer when you go on vacation. We therefore have three goods to worry about: consumption this summer, consumption next summer, and leisure hours this summer. Suppose you have no savings yet, and all that you own is 600 hours that you could be working this summer. Thus your leisure endowment is 600 hours, and you have no endowment of consumption this summer or consumption next summer. The endowment bundle E therefore lies on the leisure hours this summer axis. If your wage is $20 an hour, then you could make as much as $12,000 this summer by giving up all of your leisure. If you decide to consume all that $12,000 this summer, you would therefore consume at bundle A. You'd consume $12,000 now, you would consume no leisure, and you'd have nothing left over for consuming next summer. In the horizontal plane that's formed by the two lower axes, we therefore get a budget constraint, and this budget constraint is one that simply illustrates the trade-off between consuming now and leisuring now. It's therefore similar to the usual worker budget constraint that we've graphed earlier in this chapter. In this plane, the opportunity cost of taking an hour of leisure is the wage that you would be giving up by not working for that hour. Thus, in this plane, the slope of the budget constraint is minus W, as it usually is in the worker's budget constraint. Now suppose you indeed decided to give up all of your leisure this summer and earn $12,000. We can then look at the plane that's formed by the two consumption axes, consumption this summer and consumption next summer. You can still consume bundle A, the $12,000, this summer, or you can save some of it. If the interest rate is 10%, then you could earn as much as $1,200 in interest, in addition to having the $12,000 available in your bank account. So the most you could consume next summer is $13,200, or bundle B, if you give up all consumption this summer. In the plane that's formed by the two consumption axes, we therefore get an intertemporal budget constraint, where the slope of that budget constraint is, as always, minus 1 plus the interest rate. Notice that in this plane, bundle A becomes our endowment bundle. This is because if we operate in this plane, we've already decided to give up all 600 hours of leisure this summer, and therefore we already have the $12,000 in income this summer. Bundle A is therefore available to us no matter what the interest rate is, and therefore becomes the endowment bundle if we operate in that plane. Now suppose you've decided to not consume this summer at all. All you'll do is work now, and then you'll consume next summer. In that case, we operate in the plane that's formed by the axis consumption next summer and leisure hours this summer. The opportunity cost of consuming an hour of leisure this summer then becomes the wage that you give up plus the interest that you give up by not having that wage to put into your savings account. In other words, if you take 1 hour of leisure, you give up $20 in the wage and $2 in interest income that you could be making from that $20. If you worked for 600 hours this summer, you'd earn $12,000. You could then put that in a savings account, and if the interest rate is 10%, you'd make $1,200 in interest over the next year. This would give you a total of $13,200 you could consume next summer. In other words, you could consume bundle B again. Thus, in the plane with consumption next summer and leisure this summer, we get a budget constraint that now has a slope of minus W times 1 plus R. But you might decide to do something that doesn't put you on one of the planes that's formed by two of the axes in our graph. For instance, you might decide to consume 100 hours of leisure this summer, thus working for 500 hours. You might then decide to split your earnings between consuming now and consuming next summer at some bundle like bundle C that floats in 3 dimensions. Once you've decided to consume 100 hours of leisure this summer, you've in effect decided to restrict yourself to a 2-dimensional slice of the 3-dimensional budget set that you originally faced. That 2-dimensional slice holds 100 hours of leisure fixed and presumes that you're working for 500 hours. Working for 500 hours gives you an income of $10,000, which you could all consume this summer, or you could put it into a savings account and have $11,000 for consumption next summer. Bundle C, which splits your consumption between the 2 summers, then lies on this magenta slice of the 3-dimensional budget constraint. Notice that the magenta slice is exactly the intertemporal budget set we previously derived for the case where you have $10,000 now and you contemplate whether you should save some of it for the future. In other words, when we hold fixed your leisure decision this summer, we've created an intertemporal budget constraint and avoided thinking about how much you're going to work and not work this summer. This is generally true in economic models. We oftentimes hold lots of things fixed in order to focus on something specific we want to investigate, and thus we're often modeling slices of more complicated choice problems.